Well, some of the kids are still missing, but I'm sure they would join in due course. So quickly, let me talk through what are the things that we want to talk about today, what we want to learn today. So today we'll talk about slope of graph of exponential functions. So we started talking about exponential functions yesterday. So we'll talk about what do we mean by the slope of the exponential function. Then we will try understanding how do we shift the y-intercept of exponential graph, and then we'll talk about polynomial and other nonlinear graphs. How do we identify features of graph from polynomial functions or the zeros. Alright, so primarily we'll talk about the exponential functions and some of the properties of that, and then we'll go to polynomial functions. So we are still in the fourth unit of SAT prep, which is around foundation of advanced maths. So that is what we're going to cover. So let me do a quick roll call again and see who all are here. So we have Deep, we have Aryan, Dev, Dhanushri, Chris, both the Chris, Neil, Sarah, Prisha, Rehan, Ritika, Sunarka and Vishal. So welcome everybody. I know some of you were away due to your spring break or holy break and whatnot. So I think we are back with a bang and we'll get started. So the first thing that we want to talk about is the exponential function and how do we understand the graph, how do we understand the slope of our exponential function. So like we covered yesterday, when we talk about exponential function, what we essentially mean is a function where the power or the exponent is a variable. So if I'm talking about y as a function of x, which is equal to, let's say, 3 to the power x. This is an example of exponential function because one of the variable in this function or equation is actually the exponent. Yeah. So when it comes to recollecting what do we mean by exponential function, we should not have any doubt. If I'm talking about y equal to 2x square plus 3x minus 9, I'm talking about a quadratic equation or a quadratic function. But and in this case what we are saying is the exponent is a constant, a number. Whereas if you're talking about exponential function, we are talking about y equal to, let's say, 1 by 3 to the power x, where your variable is the exponent. So that's why it is called the exponential function. Yeah. Now what we want to know is, yesterday when we were talking about it, we were saying, okay, fine. If I have an exponential function, how do I find out the behavior of that? What are the x and y intercepts of exponential function? Here we are trying to go to the next level and try to find out what do we mean by the slope. When we talk about slope of anything, right, we are talking about the steepness, how it is increasing or decreasing, correct? How the value of y is decreasing or increasing for every corresponding change in x. For every value of x, how is the value of y derived and how is that changing or increasing or decreasing. So if you see, let's say if I talk about a linear equation, a straight line, what is the slope of the line? We are talking about how the value of y is changing for every change of x. That essentially is called the slope of a function, correct? Now, in case of a straight line, it's very easy to say. But if I'm talking about exponential function, you would have probably seen that it plots a graph like this. We talked about the vertical and horizontal asymptote, where when it hits it goes towards the direction where it hits an infinity. When we talk about horizontal asymptote or vertical asymptote. So in this case, how do you know the slope of the function? Here the slope versus the slope here versus the slope here is going to be all different, correct? We don't see in the case of a straight line, you are seeing the slope is constant. You can predict this. Whereas in case of exponential function, how do you derive the slope? Any thoughts around this one, or any questions with respect to what I have said so far? No questions? Okay. So basically, when you talk about a slope of anything, you are essentially talking about how it is increasing, how the value of y is increasing or decreasing for every change of x. So that works well in case of a straight line. But when you talk about an exponential function, where you see that the behavior could be as erratic as you can think of. Here it is pretty much getting horizontal, here it is vertical. So here it is much more steep, here it is almost horizontal, very shallow, wherein you see this changing in between. So that is essentially what a slope of a function says. Slope of a function, if you say, my slope of function, let's say, let me give you an arbit value. Okay, I have an exponential function y equal to 2 to the power x. I don't know why I'm giving always 2 to the power x, but let's say this is my exponential function where my variable is the exponent. Now, can I say that, okay, slope of my function is 1 by 3? I'm just making it up. Can I say that? Just if you look at it visually, you will not agree with me. You will say that, sir, you cannot make a generic statement saying that my slope of the function is 1 by 3, because your slope here versus the 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 slope here are all different. It doesn't seem to be a constant value, it's changing. So that is why slope of function is always determined in a given range. You see, okay, my slope of the function in case of exponential function is in this range. So let's say here, if I'm talking about this exponential function y equal to 2 by 2 power x, if I say what is the slope of function, I'll say, okay, fine. What is the slope of function for x equals to 0 versus what is the slope of the function for x equal to 1, and how it is changing. So basically the difference in value of y between 0 and 1 tells you the slope of the function for this range. So now let's look at solving this one. So let's say, what is the value of y when x equals 0? So I'll put a 0 here. My value of y is 1. What is the value of y when I'm talking about x equal to 1? So I'll put x equals 1, and so here you see that my value of y is 1 for x equal to 0, and value of y is 2 in case of x equal to 1. So value of y is increasing. So you will say my slope of the function is actually increasing between 0 and 1. That is how you kind of relate or put your thoughts around to understand what is happening. So here when you are seeing that, okay, when x is increasing from 0 to 1, my y value is also increasing from 1 to 2. So slope is positive. Is there any absolute value for this? That is outside the purview of this class. We will not try going there. When we learn calculus, that is when we will talk about it. Okay. Just in terms of just wrapping your head around this one, slope of the function at any point would be the slope of the tangent at that point, and that we will cover when we put our thoughts together to learn calculus. Okay. Whoever is interested in learning calculus, let me know. When we start learning calculus, that is when we'll talk about that in absolute terms. Here, the only objective or the goal that we have is to understand, is my slope positive or negative in a given range of value for x. Is this part clear to you guys? Sunarka, Ritika, Dave, and again, I keep repeating myself. If I am teaching something, I would never claim that I teach the best possible way. I'm just trying to make things look a little simpler to you guys. So if I don't hesitate. I'm not a very scary person, right? I mean, even if I look scary, I'm not scary, okay? That's a guarantee to you guys. feel free to ask questions and make sure that you are decoding everything that we talk in the class to make an informed decision or to build your own concepts. Is that okay? Yeah? Okay. All right. So Prisha, Neil, Sarah, Dave, everybody with me? Deep, no concerns? Okay. All right. So this was one of the topics that we wanted to cover today, which is understanding the slope of a graph of exponential function. Now, next thing we wanted to do was, what do we mean by shifting y-intercept of an exponential graph? So yesterday we were kind of dealing with some situation where we said, okay, fine. If I have, let's say, an exponential function that is, let's say, y equals 1 by 2 to the power x. Okay. Or you can say this as y equal to 1 by 2 to the power x also. Any which way, I mean, both are the same. Right? So this is the exponential function we have. And if we try plotting this, let's try plotting it real quick. And every function, every equation that you have, when you have to plot it, we'll do that like a fifth grader would do. No complexity involved. This is the equation that is given to us, and our goal is to find out y value for every value of x, because that's a deal, that's the agreement between x and y that we are seeing in this form of this equation. Now let's put some numbers real quick and see what happens. When I put x equal to 0, 1 by 2 to the power 0, anything to the power 0 is 1. When I say x equal to 1, so this becomes 1 by 2. When I put x equal to 2, it becomes 1 by 2 to the power 2, that is 1 by 4. Let's put some negative numbers also. When I say x equal to minus 1, what happens? This becomes minus 1. So 2 to the power minus 1 becomes 2. When I say x equal to minus 2, what happens? This becomes 1 by 2 to the power minus 2, or 1 by 2 to the power minus 2, which equals 2 to the power 2, because when you move from numerator to denominator, denominator to numerator, your power flips from positive to negative or negative to positive. So this becomes 4. So this became 4. So we have good enough 4 or 5 points. Let's try plotting it here. Now when x is 0, y is 1. 4, 5, 1, 2, 3, 4, 5, minus 1, 2, 3, 4. So 0 and 1, this is 1 point. 1 and half, 1 and half. This is second point. 2 and minus 4, 1 by 4, probably third point. Minus 1, 2, which is minus 1, it is 2. This point, minus 2, 4. Minus 2 is 4 somewhere here. So we see that this graph is going this way. Okay. Now, I'm not going to talk about the vertical and horizontal asymptote today. Okay, we talked about that yesterday. So let's not worry about that part right now. What we're trying to understand is, how does my y-intercept shift here? Now, when you're talking about y-intercept is the point where, when you say you have an equation or a function, when you are trying to say what is my y-intercept, that means where that graph is crossing the y-axis. Meaning, where will any graph or function cross the y-axis? Any thoughts? If I have any equation and I am trying to say what is my y-intercept, meaning where it is crossing the y-axis. When it is crossing the y-axis, what will be the corresponding value of y at that point? Sorry, what will be the corresponding value of x at that point? Yes, Dave.
So wouldn't we just set all the x's to 0?
X will be always 0. When any point that you take on the y-axis, the x value will be 0. So basically, if you have to find out the y-intercept of any function, that means you are talking about a point on the curve or the graph where x is 0. That is the only point when it will meet the y-axis. Correct? So I'll put a 0 here. When x is 0, y is 1. So what is my y-intercept? Y-intercept is equal to 1. Okay, positive 1. Now what we're trying to figure out is how does my y-intercept shift. Let's say if I have this equation, and this is my current, for this equation my y-intercept is 1. Okay, that we have seen. So you guys will not deny that, right? We have the proof of that here as well. Now let's look at another exponential equation, exponential function, whatever. Same thing, 1 by 2 to the power x and plus 2. Let's see what happens. Now, if this is my new function or new equation, we'll do the same. Kids, play here and see what happens. Let's pick 2, 3 points or same point. 0. When I put x equal to 0, this becomes x power 0 is 1. So this becomes 0. Sorry, x power 0. 1 by 2 to the power 0, that becomes 1. 1 plus 2 is 3. When I put x equal to 1, so this is 1 by 2. 1 by 2 plus 2 is 5 by 2. I'm doing quick calculation. You guys can revalidate that when you are doing it yourself. When I say x equal to 2, this becomes 1 by 2 to the power 2, that is 1 by 4. Whatever value you have, you are adding 2 to that. So 1 by 4 plus 2, that becomes 2 plus 1 by 4. So 9 by 4. Okay? Or let me put it this way. Let me say 2 plus half so that you can relate. 2 plus 1 by 4. When I go for minus 1, this becomes same 2 plus 2. When I go for minus 2, same, well, this value doesn't change. So whatever you have, this plus 2. Now let's try plotting it. And what do we see is when I have 0 and 3. So this is my first point. 1 and 2 plus 1 by 2. So 2, this is 2 here. Sorry, this is 1, 2 plus 1 by 2. So this is 2 plus 1 by 2. It will be somewhere here in the middle. When it is 2, 2 plus 1 by 4. So this is 2 plus 1 by 4 here. And I'm just making it up, okay? I'm shifting everything by this. What you are seeing here is, just look at the y-intercept. Earlier the y-intercept was, for x equal to 0 it was 1, now it is 1 plus 2, 3. Everything is shifted by 2 points. The whole graph is shifted by 2 points upward. So this is how you can relate to it. That when you have a function, if you add something or subtract something, if you put minus 2 in place of 2, you will see that everything moves by 2 points below. So basically this constant that you add to the exponential function, that leads to shifting of the y-intercept and all other points by that many points. Is it relatable or you are finding it complicated? Or even if you don't want to believe me, okay? Let's say you don't want to believe your teacher. Now you look at this. This was my x and y value table for this equation, and this is my x and y value table for this equation. What is that we observe here? In this equation you did not have a plus 2, you added a plus 2 in the second equation. What happened to every point here? 1 shifted by 1 plus 2, half shifted by 2 plus half, 1 by 4 shifted by 2 plus, 2 became 2 plus 1 by 4, 2 became 2 plus 2, 4 became 4 plus 2. Everything shifted by 2 points, and that 2 point is coming from here. So basically, you know, if you have any exponential function and if you add some number to it or subtract some number from it, you will see the graph or all the points in the graph shifting by that many points. Is it making sense? Yeah. And I'm assuming that this part is okay to digest, right? Don't eat anything that you're not able to digest, okay? So be it with any mathematical concepts also. Yeah. Dave, Sunarka, Rehan, Chris, everybody okay with this? Yeah?
Yes, good.
Sora and Neil as well?
Yes, sir.
Okay. So this was the next topic that we wanted to cover. So we had talked about how do we understand the slope of a graph. So for exponential function. So again, as I mentioned in the beginning, slope of the graph in exponential function is not going to be one constant value. You will see that the slope is always changing. Here it is vertical, becomes more horizontal, and it became literally horizontal at this point. And so you cannot have one slope for this. You always find a slope in a given range that, okay, is my slope increasing or decreasing between these 2 points? So that's the first thing we looked at. Second thing we talked about was this one. How does adding or subtracting a constant impact your y-intercept of the exponential function? And we literally saw what happened here. Correct me if I'm at all making it complicated, but the whole intent here is that anything that we see, even if you look at a function that looks complicated in nature, kill the complex part of it. Always look at any question in the simplest possible way, like a kid would do, right? I mean, you guys are all like kids only, but I'm saying any kid younger than you guys would look at it. It's a function. It's nothing but a contract between x and y. They have struck a deal, and this is what they want to stick to. What does it mean to us? With plain simple eyes, this is what it is. What do we interpret from that? That is what we saw. Correct? Let's go to the next topic that we want to cover today. That is polynomial and other non-linear graphs. Okay. So now we have looked at linear equations, we have looked at quadratic equations, and we talked about polynomials. Polynomial and non-linear graphs. There is only one type of equations that leads to linear graphs or linear functions. That is nothing but something which is written in this form. Because the maximum power to the variables is 1. This is the only scenario, where the maximum power to the variable is 1. Okay? And that will lead to a straight line. So this is the only scenario where it will be linear. Anything apart from this would be non-linear. So if I start toying around with this one, and if I say, okay, fine, I did not like x to the power 1, I made it this. This is not going to be a linear graph by any means. You put the same table x and y value and then try plotting it. You will never be able to plot a straight line like this, or a straight line like this, or a straight line like this, because you have power more than 1 on a variable, and that results into something which is curvy in nature, which we call as parabola. So would be the case if you keep playing around with this further and further and further. You will not come back to the straight line by any means. Even if you go in another direction, say okay, x to the power minus 2, same thing. This guy will again not let you draw a straight line when you plot that in the number table. Okay. So one differentiation that we have to keep in mind is, if I have an equation where the maximum power to the variable is 1, that is going to be a situation where we can draw a straight line. That's a linear function, linear equation, and that will lead to a linear graph. But anything which is other than 1, when any equation which has power to a variable, to any of the variable, more than 1, that results into a curvy outcome, which will not be called a linear equation, a linear function. And there are different situations that will come across. We have seen, if you look at this power 2, we have seen that this is nothing but a quadratic equation. And whenever you are dealing with a quadratic equation, that plots a parabola. Be it upward facing, be it downward facing, all that we have seen in the previous classes. And once we complete one cycle, we'll come back to it and we'll again talk about it. In fact, when we talk about the 8th chapter in this one, which is medium level of advanced math, we'll come back to parabola and again we'll play with that a little bit more. But net, when you have a quadratic equation, you end up drawing a parabola by same approach. Now, does it mean that we have only two variants? Meaning when x to the power, when the variable has maximum power as 1 and when the variable has maximum power 2? No. If I'm talking about this is also a polynomial because you have many terms, more than one term, and the maximum power is more than 2 also. So what I'm trying to say is anything and everything that has power more than 1 and 2, that is what will be covered as part of what we're going to cover in the next few classes, which is called talking about polynomials and dealing with the different, talking about polynomials or non-linear functions. Okay. So we'll not talk about linear functions, we'll not talk about quadratic functions or quadratic equations. We'll talk about things which have power more than 2, which we'll term as non-linear function or polynomials. Is that part okay so far? Okay. So going by that concept, again, I might be confusing you guys by saying polynomial, because polynomial has a very simple and straightforward definition, which says that any equation or expression which has more than one term is called polynomial. So if I'm talking about 4x plus 3y equal to 18, this is an equation which has more than one term. 1 plus 1 plus 1, 3 terms are there. This is a polynomial. Meaning any equation or expression which has more than one term is called polynomial. What we will cover is non-linear polynomial. Meaning this one will be ruled out because this is a linear polynomial. Even if this is a polynomial, this is a linear one. This is going to draw a straight line. And as I said, we are not going to talk about parabolas or quadratic equations. So our journey here with this particular topic will start with the fact that we'll deal with things like, here your power to the variable is 3, which is more than 2. It could be 3, it could be 15, doesn't matter. Anything which is more than 2 is what we are going to cover as part of non-linear polynomials. Is that part okay so far? At least to know the boundary of what we are going to cover or what we are going to talk about. Yeah? Okay. So I know this is post-lunch session, so some of you might feel sleepy like I'm feeling sleepy right now. I mean, I don't feel sleepy, I don't fall asleep, but yeah, there are days when I overeat and that makes me sleepy. So good news is I'm not sleepy right now, but if I'm making anybody sleep, I'll keep waking you guys up. So let's take one example of a non-linear polynomial, which is, let's say, let's pick up something simpler to begin with. X squared minus 2x squared plus 4x plus 8. We know that this is a non-linear equation for sure because the power is more than 1. And this is a polynomial also because they have more than one term. 1, 2, 3, 4, 5 terms are there. So this is a non-linear polynomial. Now, if I say find out the zeros of this polynomial, what do we mean by that? What do we mean by zero or zeros of a polynomial? In conceptual terms, don't have to try solving any complicated math. Just tell me what is your understanding of the concept. Because this kind of questions you will come across very often in SAT exam where they say, okay, fine, this is the equation, find out the zeros of the polynomial. Yes, Prisha.
What's like the solutions or the roots?
Little louder.
The solutions or the roots?
Okay. Solutions for the roots. That is one answer, and I would not say that is incorrect. But whenever I ask a question, I always make a statement saying that when you're answering the question, imagine your teacher is not intelligent, which might be true, and you're teaching a 5th grader. So now if you keep that in mind, assuming your teacher is not intelligent and your teacher is a 5th grader, how would you explain that to me? What do you mean by zeros of a polynomial? Yes, Dave.
So the zeros of the polynomials could be like when the equation crosses the x-intercept. So it
Crosses the x-axis. That is what is called
Yeah,
x-intercepts. Yeah. Okay.
x-axis,
Mhm.
and the y value is equal to 0. So you get only the x value.
So, I mean, kind of, you and Prisha, help me connect the dots. If I have any equation, any polynomial, right, a non-linear polynomial, and I'm not saying that whatever I'm going to graph now is correct. Let's say this results into this. The zero of a polynomial. This is a polynomial. When you say zero of a polynomial, you are essentially talking about when your y value is 0. And that is what Prisha meant by saying roots of the polynomial, correct, Prisha? And this is exactly what they've also explained, that these are the points when it is intersecting the x-axis, or the points where the graph is meeting the x-axis. So when you say zero of a polynomial, you are essentially saying that my output becomes 0. See, any polynomial that you talk about, this is your output based on what are the values of x you are putting here. So when your output itself becomes 0, that is what is called zeros of a polynomial. Now, how you will do mathematically, that you guys know. That okay, fine, you will kind of break it down, convert this into factor form, and then you will solve it. So if I say that okay, I have a polynomial that is, let's say, which is p of x or function of x, whatever I call it, function of x, y equal to function of x, which is equal to, let's say, x minus 1 into x plus 3 into x minus 4 into x plus 1, or let's say I stop here. So basically now when you break these brackets open, when you're using your simple mathematics, it will probably become a polynomial with maximum power to the x as 3. And I'm saying that okay, whatever equation you had, you converted that to factor form and you got this. So when you say zero of a polynomial, what you're talking about is this value becoming 0. This value becoming 0. And this value will be 0 in under certain circumstances, when either this is 0 or this is 0 or this is 0. If one of the three it becomes 0, then your overall output will be 0, right? So here, if you're looking at this polynomial, which we converted into a factor form, if you find out the zeros of this polynomial, what you're talking about is there are 3 scenarios when you'll be achieving 0, which is when x minus 1 equal to 0 or x equals 1. Second situation is when x plus 3 equal to 0 or x equal to minus 3, or x minus 4 equal to 0, which makes x equal to 4. So by looking at or just by relating what do you mean by zero of polynomial, by looking at this one, you can figure out that okay, fine. Now there are 3 places in the coordinate plane when this polynomial is touching or crossing the x-axis. If this is 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. So one point is x equal to 1. This is one point when this polynomial is crossing the x-axis. Second point is when x equal to minus 3. So this is my second point. Third point is when x equal to 4. So this is my fourth point. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So these are the 3 points where this polynomial is intersecting the x-axis. So now it could be like this, or it could be like this. So far we don't know this. At least we know that these are zeros when the value of y became 0 for these possible values of x. Yeah? Does that make sense so far? So conceptually, if you look at it, when we talked about the quadratic equations, what did we see? We saw that when we solve a quadratic equation, let's say y equal to x squared plus 4x plus 4. I'm just taking an easy example, which equals, or if I say x squared minus 4. This is a quadratic equation. This will draw a parabola. And what did we do? We said, okay, fine, this equals a squared minus b squared, that means a plus b into a minus b. So we got two values of x when x equal to 2 and x equal to minus 2 from this one. What did we do? We came to a point when we converted this equation into a factor form, and then we said, okay, fine, for us to get a 0 or the x-intercept, meaning where it is meeting the x-axis, I will make this as 0. That becomes my 0 of the parabola. And we got 2 points which says, okay, if I have this my coordinate plane, 2 and minus 2 are the points where the parabola is crossing or intersecting the x-axis. So same way here also, when we have an equation, you have to look at how do you convert that to factor form, and then when you have 3 factors identified, you have to look at which factor I can pick up to make it 0, and then identify the corresponding intersection points. So here, when we assume that my equation converted to this form, we had 3 options to choose from, and those became my potential candidates or the potential intersection points where this parabola is crossing the x-axis. So, in summary, whatever we have learned so far, that is primarily to understand if I have a polynomial or non-linear polynomial, what do we mean by zeros of the polynomial and how do we determine that? I have put few questions here, picking up from the material that I refer for to prepare for this one. So I will just handpick those questions and we'll try solving that in the class and see if whatever we have learned so far, are we able to solve some legitimate questions that you guys will come across. So let's look at one of the questions. And I'm assuming that you guys will anyways do the unit test in Khan Academy after the class to reaffirm that whatever we have learned, you are able to apply that for solving the problems that you would need to solve. Yeah. So let me read this question for you guys. This question says the polynomial px has 4 distinct zeros. The polynomial has 4 distinct zeros. Again, my most boring concept, right? I have removed t from the equation. Say, okay, trust, you always have to have read, analyze, and then do it. So that's what we're going to practice, okay? The polynomial px has 4 distinct zeros. Which of the following graph could represent y equal to px? Y equal to px. It says the polynomial px has 4 distinct zeros, okay? It has 4 distinct zeros. So there is no relationship, no connection, no commonality between those zeros. There are 4 distinct zeros of this polynomial, okay? Nobody has given us the equation. We don't really have to worry about it. What we have is, we have 4 graphs given. This is one graph. Second graph is this one, which says, okay. Third graph is this one. And interestingly, there is no value given also, okay. okay, and then this one. Okay, so these are the 4 graphs given. Okay, now with this question, I'm just reading it one more time. I'm still stuck in this place. Okay, I'm reading the question again and again. The polynomial px has 4 distinct zeros. It has 4 distinct zeros. If you recollect what we have learned so far, when we say zeros, zeros are the points where any polynomial is intersecting the x-axis. So that understanding we'll keep in our mind. Which of the following graph could represent y equal to px? It says that you just know that your polynomial has 4 distinct zeros, meaning it is hitting or crossing the x-axis at 4 different places. Which of the following is representing this graph y equal to px? Now look at this. You know that there are 4 distinct zeros. So this is when you have done enough of reading. Now you are analyzing that. Okay, fine. It's a polynomial which is having 4 distinct zeros. So it is crossing the x-axis at 4 points. What do we know by zero? That is understood. That's why we are saying that this is crossing the x-axis at 4 points. So in my mind, without looking at the options, it's okay. If I have a graph, since I don't have the equation, if I have a graph where I see it crossing the x-axis or intersecting the x-axis at 4 places, that could be the potential answer. Let's look at it. This one is crossing the x-axis at 1, 2 and 3 places. Ruled out. This one is crossing at 1, 2, 3, 4, 5 places. Ruled out. This one is crossing at 1, 2, 3, 4 places. This could be a possible answer. Okay. Now this one. This is crossing x-axis at 1 and 2 places. This is also ruled out. Do I have to do any calculation? No. Just by looking at an equation or a question, it might sound that okay, this looks complicated. I have to find out. If you look at this kind of graph, right? Trust me, I'm not sure about you guys, but I don't get to see this kind of graphs every now and then. So when I see a graph like this, I get worried. I'm more comfortable with a straight line. I'm little more comfortable with the parabolas. But when I see this kind of a fancy looking graph, I actually start getting worried. But then when I read the question a couple of times, then we realize, oh, this is an easy peasy one. It is just saying find out how many places it is intersecting the x-axis. That's it. And that we could do because we could recollect that zero of any polynomial means how many times it is intersecting the x-axis. That's it. We just have to count. So all the energy went here. Solving it was the easy one. And then another technique that you saw was, we did not worry about what is the right answer. We actually looked at a technique called elimination. As soon as we saw 3 points, eliminate, not needed. I don't want to waste my energy for this guy. 5, eliminate, not needed. 2, not needed, done. If I don't have these 3 to be considered, this looks to be the obvious case, and I just counted 1, 2, 3, 4. That's it, done. Yeah, makes sense? Did you guys find it boring, easy, annoying? What was the thing? So Vishal showed thumbs up as soon as I said the word annoying. Is it? I'm just kidding. Alright, so let's pick up another question, okay? And this might look more scary than the previous one. So, it has given a graph, okay? Let me draw this graph for you guys first. And I will not delete this because this is going to be my guiding principle. So, it has given a graph here, okay? This is 1, 2, 3, 4, 5. So minus 1 to minus 5. This is minus 4. This is 1, 2, 3, 4, 5. It says a graph goes from here, goes to the 1, 2, 3, goes to 3, comes down here, again goes up, and at 3 comes down. Okay, so this is 1, Okay, this is not coming down here. This comes down at 3. Okay, 4, 5. So this is the graph given. Okay, then it says which of the following could be the equation of the graph above. So this is the graph. It has given 4 equations. Y equal to minus x into x minus 3 into x plus 4. Y equal to minus x squared into x minus 3 into x plus 4. Y equal to minus x into x plus 3 into x plus 4. Y equal to minus x squared into x plus 3 into x plus 4. Okay, sorry, x minus 4. Okay, so far we are just reading the question, right? It says that this is the graph and says which of these following equations could be the equation of the graph that you are seeing on the board. Okay, is everybody able to see the board clearly and see what exactly is written there? So the question is very simple. I mean, question doesn't look as simple as I'm saying, but I was not really comfortable seeing the question. Say, okay, I'm just giving you a graph. Tell me which of the equation could be the equation for this graph. Okay. Now, here also we'll use the same technique called elimination, because finding out which is the right equation might be a mammoth task. We don't want to go that path. Rather, we would find out an easier approach. And that's what is the need of the hour also. If you look at these 4 equations, here you have x minus 3 into x plus 4, and outside you have minus x. Minus x squared, minus x squared is the constant term outside. Then you have x minus 3 into x plus 4, x minus 3 into x plus 4. These two have these two part common, and so is the case with the last two also. Now, when you look at x plus 3 into x minus 4, here, when you just look at this graph, it is meeting at x equal to minus 4. I mean, intersecting the x-axis at x equal to 4, minus 4, x equal to 3 here, and x equal to 0 here. These are the 3 places when it's meeting x-axis. So here you can see when this is 0, that is representing this point. All these x squared, that is representing this point. Now when x equal to minus 4, which scenario here would give you x equal to minus 4? When you have x plus 4 equal to 0, that is when you get x equal to minus 4. Yeah? Similarly, which scenario will give x equal to 3? So x equal to 3, that means x minus 3 equal to 0. This scenario will give you x equal to 3. So you are essentially talking about x plus 4 and x minus 3 being in your factors for sure. Anything which doesn't have x plus 4 and x minus 3, that you can rule out. See, here you see x plus 3, and x minus 4, when it's supposed to be x plus 4. So this option and this option you will just simply rule out. Is it making sense to you guys? So here, just by looking at the intercepts, in what scenario it will be x on this graph, it will be intersecting at minus 4. That means when x equal to minus 4 or x equal to minus 4, that means x plus 4 has to be 0. This has to be one of the factors. You see this factor being here, this factor being here, that is correct. In what scenario you will have x equal to 3? That means x minus 3 will be equal to 0. That is when you will have x equal to 3. So this and this have to be there, which you see here in this case. So both of them seem to be valid options so far. Now, what you want to do is look at these points where it is intersecting the x-axis. Look. Sit down. We still have 9 more minutes for the class. You guys will hear something that you will not understand. That's okay. Okay? That is for. Yes. So just. Okay. So Any other junior kid, if they have joined already? I see Sammy being there, but Sammy, don't get scared, beta. This is for elder kids. So even if you don't understand, don't worry about it. You are just 9 minutes early for the class. Now, here you should look at these two options. Now, in this case, these two we have already seen. Now let's look at minus x and minus x square scenarios. Sit down, sit down. And next 8 minutes, I would want you guys to just watch without being worried about anything. Okay, this is not for you guys. Okay. Now here, when x, let's look at this situation. What do we see in the graph? When the value of x is decreasing further, meaning it's increasing from minus 4 to minus 5, minus 6, minus 7, your y is decreasing. So is the case with this point also. When x is going beyond 3, when x increases from 3 to 4, 4 to 5, 5 to 6, your y value is decreasing. Y was 0 here, it's going in the negative direction. So let's pick up this situation now. When x equal to, in this case, when x becomes, let's say 4, I will not look at these two parts, I will just look at this part. When x equal to 4, x equal to 4, this is 4 and this is minus 4. So y is negative. This looks to be okay. But in this case, okay, let's look at first equation first. Okay, so when x is increasing from 3 to 4, this becomes 4, that is minus 4, y is going negative, that's okay. When you make it 5, x equal to 5, when x becomes 4 to 5, you see y further decreasing, minus 5. This seems to be okay so far, first equation. So let's look at this situation. When x becomes minus 5, minus 4 to minus 5, y is further decreasing. Here in this case, if x becomes minus 5, this will become minus into minus plus 5. Meaning y value is becoming positive. When x becomes minus 6, it will become minus 6 into minus plus. So plus 6. Y is further increasing. It became 6. I mean, I'm not looking at this part, I'm just talking about this first one. So basically, first equation looks to be okay when you're looking at the positive side of it, but when you go to the negative side of it, you see that it is not falling in line with what we see in the graph versus what is the outcome that you are seeing here. Is that making sense, or I'm getting you guys more confused? Not for you. And Rudraksh, I will not entertain that. Please don't poke your nose into something that is not for you guys. Okay? Everybody. Okay? So here, what you see is, I'm again repeating myself. When you look at this equation, this one was y equal to minus x into something. I'm not looking at these two elements, I'm just looking at this one. Here, when x increases, I see that y is decreasing. So this one, x becoming 6, becoming 7, it becomes minus 7. So this y is decreasing, that looks to be fine. But when I go to this side of the graph, I see when x is decreasing further, my y value is increasing because it's a negative value and getting multiplied by negative. So this doesn't seem to be right for both the scenarios. Now let's look at this guy. What happens here? When I'm looking at x increasing, x increases, x squared also increases, this remains positive, and y value is decreasing. When you go to this side, no matter what value you're looking at, square of negative value will always give you positive, and hence y value will be always negative. That means y is decreasing. So net, this one seems to be the right option. Without doing much of a calculation, it was more of a correlation that we were trying to draw by looking at the equations, right? We just looked at these two, doesn't fit the bill, ruled out. Looked at this one, this side of, when x is increasing, y is supposed to decrease, but we saw this was increasing, that was fine. I mean, y was decreasing, that was fine. But when you went to the negative side of it, again when x was further decreasing, it was supposed to, y was also supposed to decrease, but just because you have a multiplication with minus, so minus 6 times minus makes the y positive 6. And that tells you that, okay, in this situation it was supposed to go this way, which is not the case. So this equation doesn't seem to be representing the graph that we are seeing here. And then when we looked at this guy, we saw it was falling, falling in place or relating to this graph. So that is how we came to the point that this would be our right solution. Let me stop here and check with everybody that I've been saying something for last 5-10 minutes and I'm kind of trying to explain that, but is that understood by everybody or I'm kind of forcing you guys to believe so? Everybody understood? Chris, Rehan, Dhanashri, Sarah, Neil, everybody? Yeah? So if anybody was having any problem in following this, you always have a solution for this. You have to probably watch the video one more time and try solving it yourself. I mean, don't go by the way I'm narrating things. You can also visualize this and put some values and just look at it. You don't have to remember or memorize things by the formula. Rather, try giving some examples and see if you are able to derive some interpretation from that. Okay? Aryan, okay beta? Alright. Okay, so I will let you guys go and request you guys to watch this video because we have not done anything new or fancy here. We have just tried relating the concepts that we have already learned and we have tried applying that in some of the formulas to see if our understanding of things is good enough for us to be able to solve this. And since we have whatever we have covered, if you guys can spend half an hour between today and the next class and try doing some unit test on these topics, that will at least reaffirm that whatever you have learned, you are able to use it. If you get stuck somewhere, ask me questions and we'll figure it out. Okay? With that being said, I will let you guys go.